Okay, so we are going to talk about number one from the homework. Number one, and for those students that were here this morning, it was my battery was out. Did you know they make a quadruple A battery? Yes, for the pen, yeah. It takes one quadruple A battery. I didn't know that. The tiny, smaller than triple A. Anyway, okay. So in number one,
I would assume it's smaller than triple A. Triple A is smaller than double A.
well, I'm just saying that, like, I didn't realize there was a battery in here.
Oh, yeah.
No, I mean, I thought there might be like not like a normal battery, like a battery that's like for the pen. It's just like a traditional battery. I didn't know there were quadruple A batteries. Double A, that's all I need. Okay, that's not true. We needed D batteries for my son's new racetrack he got for Christmas. Man, he loves that thing. This is a real quick story about Liam. You don't care who's listening, that's fine. So, Liam is almost a year old. He'll be a year old next month. Not that late, different February. And so this racetrack, let me try to paint you a word picture. So it's kind of like loop-de-loop. So you like put a car on and it keeps going, like it never stops until you like hit it or turn it off. Okay? So Henry doesn't like when Liam plays with it because it's Henry's and he's just like, get away, Liam. So, and he's kind of really physical. It's not good. Anyway, we're working on it. So there was one point where Henry was like doing something else, and so Liam crawled over and he turned it on. He like moved the thing. And I was like, whoa, what? Turn it on. And then he like looked at me. And I was like, oh hey. And he picked up a car and put it on. Yeah. And I was like, and it worked. It kept going. And he like looked back at me. I'm like, this is getting weird. So he's going to be our genius, clearly. He'll be the one we pay to go to college. Okay. Number one. I hope my kids watch these some days. All right. Number one. Always. The meanest. Okay. So we have information about the duration of a human pregnancy can be described by a normal model, so a capital N. All right. Anytime you do a normal model, you need a mu and a sigma. Okay. You need a mean and a standard deviation. Now I'm using mu and sigma because these are coming for a normal model. So in this problem, it says the mean is 266 days, and the standard deviation is 16 days. Okay. So in part A, it says what percentage of pregnancies should last between 270 and 280 days. So the first thing I do when I read this problem is I just draw like a small bell curve. Okay? And right down the middle is 266. So if it's asking about 270 and 280, the first thing I notice is that both of those are above or over 266. Now the first one is just barely over, right? There's 277. I don't know why I put 77 on that. 270. And here is 280. Okay? That's hard to see there. But ultimately, I'm looking at the percentage for in between those two numbers. Okay? So this problem is asking you to find that area that I just shaded. And the way we're going to do that is by finding z-scores. Okay? So I'm going to find a z-score for 270 and a z-score for 280. And that underline is not a fraction bar. So I'm going to be very clear. Just underline it that I'm doing my work for 270 there, my work for 280 over there. Okay? Not division. Okay. So the formula that you're going to get tomorrow that I'm going to use here is z equals y minus mu over sigma. Okay, I'll give you this formula tomorrow. So for 270, that's going to be z equals 270 minus 266 over 16. And then for 280, it'll be 280 minus 266 over 16. So you can use your yellow calculator to find the two z-scores that we're going to use. The first one is 0.25. Now, do you guys remember when we noticed that they were both above the mean? They're both going to be positive because of that. Okay, and what about for 280? 0.875? I think you put 18 in the bottom.
Oh, yeah.
There you go. You're good. Okay. So from here, you can move to your phone, but I'll just show you the notation for like how you would write the answer. So the probability that your z-score is in between is less than 0.875, but greater than 0.25. That's technically the notation for the answer. All right, so the computer will tell us what that is. All right, and I'll have the Chromebooks for tomorrow if you need them. Okay, so I'm going to go to that link that I sent you. Bless you. All right, so this is in that email I sent last week. So you can take your phone out if you don't have it out and click on that link. And where it says min, I'm going to put my lower z-score, which is 0.25. And where it says max, I'm going to put my higher z-score, which was 0.875. And then you should see, first off, see the sketch here. This looks similar to ours. And then the answer here, 0.211. So 0.211. So if I was writing like a statement of what percentage of pregnancies last between those two numbers in terms of the days, I would say about 21%. So about 1 in 5 women for those 2 days. So questions on A. Questions on A. I thought 0.875 was not rounded. You mean it for my answer? Oh yeah, I rounded. Yeah, I got 0.2105067214565.
So, based off this format or like the notes that we took class?
It's going to be, why don't I do this? Why don't the last part of class, I'll focus your studying for tomorrow. Okay?
So that's not the answer.
I sent the email on January 7th, 8th, 9th? 9th, thank you. Sorry.
Is this not the answer?
The answer is technically when it says what percentage of pregnancies should last between those 2 days, that's the answer. 0.211 or 21.1%. Either one, yes. I write percentages when I do a statement, right? The percentage of pregnancies that should last between 270 and 280 days is 21.1%. Okay? Now, I was talking with a few students earlier this morning that I hope you see this problem is something we've already done. We did this actually, I think, in October, September. We did chapter 6. So we've already done it. All right, let's look at B. All right, it says, at least how many days should the longest 25% of all pregnancies last? So again, I'm going to draw a curve. But you should actually notice in this problem, different from part A, right? In part A, it said between 270 and 280 for days. They're not giving you any days. They're asking you to solve for days. And they're giving you what? A percentage. So they're actually asking you to sketch this 25% here and to find out what days is associated with that z-score. Okay, so that right there is 0.25. Now, I know it's been a long time, so you probably don't remember this, okay? But if you go to that Desmos link, you might notice something underneath what we just did. This one right here is my inverse norm to go backwards, okay? So I'm going to go backwards. I'm going to type in here the percentage. Now, here's the problem, guys. When you do this, all right, all these calculators you use, including the Desmos, any calculator you find online or whatever that does this, it's always going to ask for the area to the left of the z-score you want. So this is the area to the right of my z-score that I want, right? So what's the area to the left? 0.75. So I'm going to type into the calculator, into Desmos, 0.75. And that will give me the z-score. So do you guys see where the 0.1586 number is written? Click in there and delete that so that it is 0.75. And then close it, and you should see the z-score associated with that is 0.674.
And you put 20.25 on the right side because it's
the longest, yeah. So it's talking about the longest 25% of all pregnancies, so to the right. It said the shortest 25, I'd be doing to the left, and I would have typed in 0.25.
And that side would have been.
This, so if I would, the shortest one, the shortest one would have been here, and because it's to the left of that z-score I would want, I actually could just type in 0.25.
Oh, okay.
Right, so you only have to think like, okay, what's the other way whenever you want to the right, right? In this case, we're shading to the right, so we have to kind of like trick the calculator. Okay, so let's use that same formula. Z equals y minus mu over sigma. Let's plug in. Okay, let's plug in what we know. What do we know? We know z, very good, so that's going to be 0.674. And if you wanted to get a more accurate answer, you would not round like I just rounded. So my answer won't be technically correct. You'd want to not round if possible. So if you were like me in high school, I would have written down 0.6744897509196. All right, that's what I would have done. All right, but now that I'm a teacher, okay. So equals. Do I know why?
No.
I don't. That's what I'm solving for. That's days. But I do know the mean is still 266 and the standard deviation is still 16. So this is going to come back to you. We did this in the fall. This is where you have to use algebra to solve for that y. Welcome back. Okay. So now you should use your calculator. I would multiply both sides of the 16, so you move it over by multiplying 16. So the 0.674 times 16, and then add, Jarvis, you right? Add the 266. We're doing the homework number 1. And then after we're done with this, Daisy, I'm going to focus your studying for tomorrow's quiz on what I would look at. Did you get something, Jarvis?
276.
Okay, so like 277 days, just under?
Yeah.
Just under 277? Okay. Okay. How do we feel about doing those problems? Because that was stuff that we really are just reviewing from the first semester. I want to get into part C and D because that's the new stuff. That's the stuff we focused on last week. Okay.
No, I want to say.
Just wait. Oh, whoop, 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 whoop. Good. Okay, so now we are moving to, in part C and D, a different idea for this problem, because now we're focused on a certain doctor, and he or she provides prenatal care to 60 pregnant women. Okay, and we are going to look at the average length of these 60 women and their pregnancies. Okay, so in part C, it's asking you to describe this distribution for this sample mean. Right? That's what we did on Wednesday of last week, sampling distribution for a sample mean. All right, so I was talking with some students this morning. Here is where you would be thinking about your assumptions and your conditions. All right, so if you need to take out your notes, you can. Well, what are the assumptions that I need to make about this sample of 60 women? Independence, right? So one woman giving birth and however long her pregnancy was does not affect another woman that's in this 60 and her duration of her pregnancy. What do we think? Do you think that's plausible?
Yeah.
Yes, I think I mentioned maybe they're related, like sisters. All right, so maybe that has something to do with it. I don't know. All right, but I can't really think of a reason that they would have any impact on, anyone else. Okay. Now, what two conditions should you think about? The randomization and the 10% condition. Okay. Does it say anything about random here?
No.
It doesn't. Do you remember that statement we wrote last week when it doesn't mention randomness? You do. These
60 women are a good representation of
the population of all pregnant women. All right, so that's what I would write. I would write these 60 women are a good representation of all pregnant women. These 60 pregnant women are a good representation of all pregnant women. Now, do I know if that's true?
No.
I don't, right? It doesn't give me a whole lot of information about where this doctor is practicing. All right? I don't know anything. I don't even know what country they're in. Okay. All right, but that statement will cover it. All right, now for the 10% condition, you can actually do the math here. Take this 60. Thanks. Take this 60 and multiply it by 10. Okay, you get 600. So as long as there are more than 600 women, pregnant women that are living in this general area of where this doctor practices, then I'm not worried about that 60 women being too big. Okay? I don't know. Welcome to life. I don't know.
So how do you use that consistency?
I do that math. I would do 60 times 10. So 60 times 10 is 600. And then my statement would say, as long as there are 600 or more pregnant women in this general area that this doctor could see if they wanted to become a patient of his or hers, then our sample size is not too big. That's ultimately all I can do, Catherine, because I don't know enough. Okay, so let's transition to the other assumption. All right, we just said we think that 60 is not too big, all right, but we need to make sure it's what? That it's large enough. So that's called the sample size assumption. So you're going to write, I believe the 60 pregnant women is a large enough sample. I believe that the 60 pregnant women is a large enough sample. And it shouldn't surprise you, but tomorrow you will be asked to make these assumptions and check these conditions. Okay? Large enough sample. All right? And that's a statement I always use, Edgar. All right? I'm not going to give that to you on the formula sheet. All right? So make sure you memorize the assumptions and the appropriate conditions. Yeah, so for this one, because it's an average, because we're talking about the average number of days, not a proportion, right? If this was proportions, then I could do the success-failure condition. That's the n times p and the n times q. You could do the math to make sure your sample's large enough. Because this is not happening here, I have to think about the large enough sample condition, and this harkens back to what does the population look like? And we actually just did that. You guys remember at the very beginning? What did it tell me about the population of all human female pregnancies? It's normal, right? So if the population distribution is normal, then I really don't need to even worry about the fact that 60 pregnant women is a fairly small sample size, right? I talked about this last week. If the population model looks skewed or bimodal or somehow does not look normal, then I would probably need that sample to be larger to feel better about using this sampling distribution. Okay? Now again, if this is proportions, you don't do that condition. You do the success-failure condition. All right? Check out the videos. It's all there. Okay? Make sure you know that for tomorrow. That's the first quiz. You want to start off strong. All right, so let's specify the model for this sampling distribution model for this sample mean. All right, we're still going to have a mu and a sigma, okay? But because we're talking about a sample, it's not going to be 266 and 16 anymore. It's going to be 266, and the standard deviation is going to be about y bar, right? That's sample mean, which I put in the problem here. Y bar. I still haven't figured out in Word how to put a bar on top, so that's why it says y hyphen bar. So sorry. Right? But you guys know when I open up some, like a pub or a restaurant later in life, it'll be called Y bar. You know, that usually gets a little bit of trouble. Okay. Tough day. Okay, just brush it off. The formula that you'll be given is sigma over the square root of n. You'll be given this formula. All right? Sigma, the population standard deviation, divided by the square root of the sample size. For this problem, that's 16 over the square root of 60. All right, so use that calculator to write down our standard deviation. 2.06, 07. All right, I think earlier today I used 2.1. You can absolutely use 2.07. I think 06, even another digit. That's fine. All right, I used 2.1 because we haven't rounded at all. So I just went one decimal place after. All right, now, this is not really asked in this problem, but I want to take a few minutes just to show you the difference between what we just did here and what we did in part A. Right? If I draw my curve, you don't have to write this if you don't want to, but if I do my model for these 60 pregnant women, I'd have 266 in the middle, and then remember, how many standard deviations do I move above and below? Well, this time, I don't move, you're right, Leslie, you're thinking of the 60 in the earlier one. Now I use 2.1, right? So if you multiply that by 3, that's 6.3. So what's 266 plus 6.3? 272.3. So that means your longest duration, all right, for these pregnant women, for these 60, is going to be about 272 for days, okay? And your shortest that you'd expect is the same thing, 266 minus 6.3, right? So 259.7, right, about 260. But guys, think about what we just did. We just talked about all pregnant women, and in that model, if you were to go 3 above and 3 below, you're talking about 16 times 3, which is just under 50, right? So you're talking about over 300, all right, and just over, all right, just over 200. That's a big difference. Talking about almost a 100-day difference. But here with these 60 women, you're talking about not even 2 weeks. That's not even 2 weeks. Okay? That's a big difference in how spread out your model is. Okay? So just keep that in mind when you're calculating these new models, right? The sampling distribution models usually have a much smaller standard deviation, a much tighter, all right, variation or variability or spread. Okay? It's not in the problem. I just want to reference it, all right, because it might be on some of the questions we do for the test. Okay, let's do D and then we'll be finished. What's the probability that the mean duration for these patients, so these 60, will be less than 260? Okay, so I draw my curve. And right down the middle is still 266. But now 260 is what? Really far to the left, right? It's way out here. And it says less than. So I'm shading to the left. So I want to find the z-score for 260. Now this z-score formula, I know you're going to think it's the same. We're going to do the same work, but the notation is different. Now we're going to write y minus y bar, because we're talking about a sample mean, over sigma divided by the square root of n. Okay, that's standard deviation for y bar. So it is different, all right? And I will be giving you both formulas tomorrow, so you just have to know which one you should be using. Okay, so 260 minus 266 divided by 16 over the square root of 60. I know, Charlize, you mentioned you said 2.07. I rounded to 2.1. What I would say personally when I do these is I don't round. Like, I don't put over 2.1. I would just go back and put it all into the calculator. That way, my rounding happens at the very end. Okay? It's not wrong. I'll still give you full credit. But just get in the habit of trying to wait till the end to round. All right, so I know it's negative because 260 is below 266. All right, so what is our z-score for 260 in this problem? Negative 2.904. So almost negative 3, right? So if you've got a pregnant woman who gives birth and her pregnancy was less than 260 days, just by looking at that negative 2.904, I know that's very unusual. It's unlikely for these 60 women. Okay, so let's do the actual answer here. The probability that z is less than 2.904. And we're going to go back into Desmos, that link. Desmos. Okay, now this time, because I'm shading to the left, my minimum is going to be negative infinity. So you know that my preference is to put negative and then a bunch of 9s. And my maximum value is going to be that z-score, negative 2.904. All right, and as I expected it to be a very low number. It's not likely out of these 60 women this is going to happen. 0.002, so not even 1%. So 0.002. Okay, so the probability that this is going to happen is less than 1%, 0.2%. Okay.